Alright guys, so let's talk through and review the steps for adding and subtracting polynomials. It does have the steps listed right here. You can remove parentheses by distributing the plus or minus sign through the second polynomial. It's really distributing the minus sign. Okay, that's going to be the big issue here. With addition, again, you can kind of just drop the parentheses and combine like terms. I'm going to talk you through how I like to code my like terms, and then we just need to make sure that we write our answer in standard form, so from highest exponent to lowest exponent. Alright, here's a case where it's addition, and if you distribute a positive 1 to these terms, that doesn't change the value of anything, so we can go ahead and ignore the parentheses and just start to code our like terms. It doesn't look like we have anything else raised to the power of 3. Okay, we do have something raised to the power of 2, and it looks like we have constants. Okay, so those are the only ones that we can actually combine. So let's start with the highest power and work our way down to the lowest. So this one's the highest. Okay, done with that. Then the next highest one is to the fourth. Done with that. The next highest one is to the third. Now we can combine these like terms. Negative 1 plus 3 is going to be a positive 2c squared. And last but not least, 7 plus a negative 3 will give us a positive 4. Okay, there's no other like terms that we can combine. And it's written in standard form from the highest exponent to the lowest exponent. So we are done. Okay, next example, it's still addition, so we can go ahead and ignore the parentheses and code like terms. Those are both w raised to the power of 1, w raised to the power of 2, and then it looks like we have constants that we could combine as well. Alright, starting with the highest power. Next highest power is 2. We'll combine a positive 4 plus a negative 1. Excuse me. And then I have a 1w and a negative 7w. If you combine that, that'll give you negative 6w. And last but not least, a negative 3 and a positive 9. Nothing else to combine, and my answer is written from the highest exponent to the lowest exponent. Alright, last case with addition. Again, with addition, distributing a positive 1 doesn't change the value of anything, so we can drop the parentheses. I can begin to code my like terms. And it looks like that's all we have coded. Starting with the highest power, negative 3 plus 1, that'll be negative 2h to the 6th. Next highest power, 7 minus 6. It's going to be 1. h to the 4th. And again, you don't have to write the 1, but I just wanted you to realize what it was simplifying to. Then we just have h squared. And last I have a positive 5. Therefore, we are done with this example. Alright. It's the minus that you have to be really careful with, because when you distribute a negative 1, that actually will change the value. So we now have negative 5x plus 6 plus 4x squared minus 2x squared minus 3x plus 1. Right, distributing that negative is just going to change the sign of every term. Now we can code those like terms. Those are like. Those are like. And last but not least, starting with the highest power, 4 minus 2 will leave us with 2x squared. We have a negative 5 minus 3. That'll give us a negative 8x And last but not least, a positive 6 and a positive 1. All right, last example with subtraction. We will distribute that minus sign to both of those terms. That will give us negative 5c to the third minus 11c. We can code those like terms. And starting with the highest power, I have negative 1 minus 5. That'd be negative 6c cubed. I have positive 6 minus 11. That will be negative 5c. And last but not least, we just have that constant to attach on the end. All right, and that concludes our review on adding and subtracting polynomials. Next thing we're going to review is how to multiply polynomials. And when I introduced polynomial multiplication at the beginning of the year, I taught you two different methods. The distributive method and also the box method. For the distributive method, let's fill in these blanks. We're going to distribute each term in one polynomial to each term in the other polynomial. Remember, this is big. Remember to multiply the coefficients. But then you're going to be adding the exponents. Next step would be combine like terms, and then as always remember to write your answer in standard form. Next we have the box method. We're going to take each term of your polynomial and line it up with a row or a column. Be sure to bring all signs, like positive or negative, plus or minus signs with the term. You're going to multiply each term and combine like terms, and as always remember to write your answer in standard form. So let's flip this paper over and take a look at a few examples. All right. We had the distributive method, example 1, and we're also going to do it with the box method as well. For the distributive method, we have a monomial times a binomial, so there's going to be two different arrows. 4 times 2 gives us 8. X times x gives us x squared. Next distribution, we have 4x times 3, which would give us 12x. You could have also done this with the box method, but you'd have to create your box. So since it's a monomial times a binomial, okay, notice I have a 1 by 2 column table. Again, we're still going to multiply these. So 4x times 2x is 8x squared. 4x times a positive 3 is a positive 12x. Therefore, my final answer is 8x squared plus 12x. Just like we found with the other method, just a different way of thinking about it. Okay? All right. Now we're doing a binomial times a binomial, which is going to require you to FOIL. It's the biggest mistake that I see. Okay, so let's make sure that we take care of this understanding today. We have m plus 3 times m minus 9. Okay, first, that gives you m squared. Outer, that gives you negative 9m. Inner gives you positive 3m. And last gives you negative 27. Okay, I do see like terms that we could combine in this instance, so let's go ahead and combine those for our final answer, giving us m squared minus 6m minus 27 as our final answer. We could have also come to this conclusion with the box method. Since it's a binomial times a binomial, you could put either binomial on either side. I have an m and a positive 3 for one of them, and an m and a negative 9 for the other one. M times m is m squared. That's going to represent the first. Okay, then we have m times our negative 9, so negative 9m. M times 3, which is 3m. And negative 9 times a positive 3 gives you negative 27. Now right away I see that these are like terms. So when I go to write my final answer, I can start with my highest exponent, work my way down, but I'll go ahead and combine those like terms as I bring it out of my box, just to save a step. Okay, example number 3. We still have a binomial times a binomial. This is just a slightly different representation, right? Squaring something just means you're multiplying it to itself. So let's go ahead and start our FOIL method. That would give us 4w squared minus 6w minus 6w plus 9. I do see like terms that we can combine, giving us 4w squared minus 12w plus 9, which is our final answer. We could have also done that with the box method or the area model, right? 2w minus 3 times 2w minus 3. We multiply the first box, that's 4w squared. The next box, that would give us negative 6w. The next box would also give us negative 6w. And the last box would give us a positive 9. Now right away, I see like terms we can combine. So when we bring this down to write the final answer, we'll start with the highest exponent. We'll go ahead and combine these like terms. And we arrive at the same conclusion with either method, as we should. All right. For a little bit of practice, guys, I want you to go ahead, pause the video. Okay, then once you are done working out 1, 2, 3, and 4 completely on your own, pick back up and play the video again just to see the final answers. So go ahead, pause it now, otherwise you're going to see the answers. All right, and these are the final answers. How did you do? If there's one that you got wrong, maybe follow back through, follow my arrows, or maybe even try a different method. If you use the box method, you should have still arrived at the same conclusion. Okay, so now that you're done with this, you can pick up your homework assignment and get to work on that practice. Thanks.